Thank you very much, and welcome everybody. I'm glad to be speaking in a physical conference in Italy after a few years. I'm Italian. I'm not speaking in Italian because I've been working across the globe for the last 10 years, and I don't think I can actually speak in Italian about work. So you get the English version. Welcome to this talk. It's talking about event-driven application with Flask and Kafka. It's a beginner talk, not because I think you are beginners, but because I'm a beginner, especially with Flask. So expect some beginner content, but we will go in deep in how those two tools work together. I'm a senior developer advocate at Ivan, which is an amazing company, and we do open source data platform as managed services on top of the cloud of your choice. We are using a lot of Python and we are hiring, so if you find anything that I said interesting, come to me after this talk. So let's start. The title itself, it's pretty huge. So what I like to do is cut the title in pieces. Let's start with talking about event-driven application. What are those? Any guess? Well, I believe all of us try to use or are using event-driven application in our day-to-day life. Because, you know, take this example. We use our phone to select a restaurant, to select the food that the restaurant is offering, and to place an order. What we do when we hit on the create an order is we create an event, which is then processed and sent to a chef of a restaurant. This chef is actually acting as an event-driven application because it's reading the event, it's reading the order, making the food. But then the chain of events doesn't stop here, because the chef, once the food will be ready, he will create another event for the delivery person to come and pick it up. And then the person doing the delivery will actually probably create a chain of events. Because, you know, we all like to know where the delivery person is, when I'm going to receive my pizza. The thing here is this dot in a map is relevant only if from the time that is taken from the mobile phone of the driver to the time that it lands in our phone, if the delay is of 10 seconds, 5 seconds, 15 seconds. If the delay is 5 minutes, the information of the dot becomes irrelevant. This is why we need to create event-driven applications, because we need to move the data around and we need to interact as soon as possible to events happening. So, first part of the talk, or the title, I believe we all set. Let's talk about technology. The title, the talk itself, has two technologies. The first one being Flask. I'm at a Python conference, so I believe Flask is something that a lot of people will already know. But for me, I'm more a data guy, so when I tried to understand what Flask was, I found an interesting thing. I found that Flask, it's an easy way to set up web application. Because you only need to know, or to say, the endpoint, in this case, my page, what methods you want to receive from that page, in this example, both get and post, and then you define a function, and you define what this endpoint will do in case of post, and in case of get. It's, in my point of view at least, as simple as that. With like few lines of code, you can create beautiful web applications. Is everybody with me now? All good? Is Flask okay for everybody? I believe now we can move to the other. What is Kafka? What is Apache Kafka? Apache Kafka, as the name says, it's an open source tool, part of the Apache Foundation set of tools. What is Kafka? It's simple and not simple at the same time, because it's a streaming technology. And when I tell you streaming technology, I believe you all start thinking, hey, but I have Netflix for that. Kind of. Kafka, it's about data streaming. With Netflix, you can only stream shows, stuff like that. With Kafka, you can stream any kind of data. But if you go and check the basic of Kafka, what Kafka is, it's a really simple concept. It's a concept of a log. A log where you can have one producer, one application that produces data to this log, and produces an event, and we write the event in the log. We produce another event, we write the event of the log. Then, you know, the reality is not as simple. We can have multiple producers, and they can write multiple events. And if you see in our log, we always have the events in the right order. But now, since we are doing streaming, we should also consume these events. And we can have one consumer, and this consumer will receive all the data from the log, which in Kafka terms is called a topic. So even if now the producer creates a new event, we immediately, I'm on the opposite side, receive it from the consumer side. Now, I want to share you a little difference between Kafka and other streaming technologies. With other streaming technologies, once you read one event, the event itself is deleted from the queue, from the topic, from the log. With Kafka, this is not true. With Kafka, we keep the data for as much time as we want, so we can make the data available for other consumers. So this new consumer pops up at a certain point, and will receive a copy of the data. The beauty here is that you may say, well, you know, if I create events, I want to consume the event only once. And that is correct. But maybe you have different applications, different part of your company that will need to read those events. With Kafka, this is coming for free. Even more, Kafka keeps internally a setting on of until which point each of the consumer was reading the list of events. So if consumer 2 disappears for a network problem and then reappears after 2 hours, Kafka will know until which point in the log the consumer was reading. So this consumer will not have to read from the beginning, but will be able to read exactly from the point that it stopped. Another interesting thing, we always have the log, but now we have one consumer, 2 consumer, but if you check really well, those 2 consumers are equal. Those 2 can be 2 threads of the same application. If we think, for example, let's use always the food analogy. If we think about 2 chefs of the same restaurant, they want to read all the orders from the queue, but you know, they don't want to read the same order twice. They don't want to make the same pizza twice. So how can we handle this with Kafka? The trick is that we more or less don't have to handle on client side because Kafka handles it on server side. Because Kafka internally creates a topic, but manages the topic in partitions. And we can define with the event key, with the message key, where each event, in which partition each event is going. Now, when we have multiple consumers that are part of the same application, Kafka will basically send to each of the consumer only a subset of the data, only the data coming from one partition. Like in this case, the top consumer is receiving only the square events, the bottom consumer only the circle events. This is what we call in Kafka consumer group. So 2 threads of the same application will be part of the same consumer group. If you have 2 different applications that they need to read the same data for different reasons, they will be part of 2 different consumer groups. So let's do one step more. Why does these 2 technologies make sense together? Well, I've been in the data industry for a long, long time. And one thing that I always found in a lot of companies is that you have an application that produces data, and this data usually goes into some sort of database or queue or streaming system. But then you have something that reads from that streaming system and does some computation and puts this computation into another system. And then you have this other data going to a database. But by the way, the original stream was also read from another program that was doing some different computation and landing the data into a different platform. And another robot, and this could be a website. And by the way, there is also another technology that does some other changes, push it to another topic. And by the way, this is the notification that you receive in your phone. This is kind of the complex system that I've seen in a lot of companies, and I believe the companies that you work for will have something similar. The key here is that if you check in the picture, we can see some familiar trends. The first one this could be an application in Kafka. That could be a producer of data to Kafka or a receiver of data from Kafka. And also, we say something else. All these little middle ends could be Kafka topic. The beauty of using an application like Kafka is that producers and consumers of the data can speak different languages. We are in Python. Python is beautiful, but there are also other languages. There are ETL tools that can extract and do data transformation. With Kafka, Kafka doesn't care about what language the producer and the consumer speaks. You can speak different language. You can speak, of course, the same language, but you're not tied to speak. What you need to agree on is only the data format that you're using to push and to retrieve the data. So it's time for a little demo. I hope I will be able to do the demo, but since my company offers all the data infrastructure in the cloud, it depends by the network. I'm going to demo a pizzeria, which will receive an order. You have the URL of the GitHub repository at the top, where you will be able to check the code. I want to say one thing here. I'm going to do a demo about pizza. I'm in Italy, I'm Italian. I don't want, so what the pizzas that I will show you are not a suggestion about the pizza that you will have to take. It's just an example. Okay, now let's try this out. Can you all see this? Okay, this is my Kafka. It's running in Ivan. We have also an open search that we will maybe use a little bit later. Now, let's go to the code. This is my application. I'm doing a bunch of imports, setting a little bit of constants, and then the first thing that I'm doing, I'm declaring a Kafka producer. All I need to say when I declare a Kafka producer is, where do I find my server? How to authenticate? I'm using SSL and 3 certificates that I'm passing. And since Kafka really doesn't care about what you push to Kafka, I need to take whatever format I have my data in Python and create a stream of strings, basically. So I'm serializing my data for both the message value and the key. Then I'm declaring my application in Flask, and I'm declaring the index with both methods get and post. Let's move to the get. When I receive a get to the index, I will show an index HTML page, a standard page, and we will see that later. When I receive a post, this kind of web page will be my homepage of the website, where I will allow people to come and place an order of my pizzeria. When I receive that order, what I'm doing is I'm using my producer to send a message to Kafka, to the topic. I'm using the caller ID, the person making the call, in order to define to which partition a certain message goes to. And then for the value, I'm setting the caller ID again, the pizza which the caller is ordering, the address that is the caller wants the delivery to, and the timestamp of the order. So now let's try to check this in action. If this works. Okay, should work. Can you see this? Maybe it's a little too... There we are. Okay, let's make things really simple. The caller can either be a fox, a unicorn, or a giraffe. Easy. List of pizzas, amazing list of pizzas. Olives, mushroom, eggplant, garlic, onion. Do we have some international people here? We have pineapple and sushi also. And the address that anybody can write. So let me send an order for Fox, pizza with olives. Everybody's okay with that? Okay, the order seems to be submitted. How can I check? Well, let's go back to the code. I have first of all, function that allows me to stream back the result to the web page, but then I have a web page, Pizza Makers. With Pizza Makers, I create a consumer that will consume data from Kafka. And I tell that it's part of a consumer group. Remember, if I create multiple threads of the same page, this will start the concurrency. I'm always connecting to the same Kafka servers, and before I was serializing, now I'm deserializing the same information. And then I start consuming from the topic, and I start a loop. Every time I consume, I receive a message, I pass it to the front end. So let's now try to check this out. Okay. This endpoint was pizza makers. Yeah, there we are. Okay, the web page comes back. Now it's starting the consumer, and I should see, there we are, the original order from Fox ordering pizza with olives. So he went back and found the first order. But now all this should happen in streaming. So if I send an order for unicorn with pizza with garlic, immediately I have that on the consumer side. Giraffe, pizza with eggplant. Again, if the network allows me to work, yes, it arrives. Now I want to show you the concurrency bit. So what if I create a second pizza maker, another chef in my restaurant? Let's put the second chef on here. Okay, it will start the consumer. And now remember what I was doing before. When I was producing, I was using the caller ID in order to define which partition was getting a certain order. So what it will happen now is that depending on the caller, we will see a row happening at the top or at the bottom consumer. Let's try with Fox and pizza with mushroom. We see that appearing at the top consumer. Unicorn and pizza with onion, top consumer again. Giraffe and pizza with pineapple. Do you agree? Is not happening at the bottom consumer because I believe the network is not really stable. Yeah. Sorry for this, but my network is not playing really well for me, with me, sorry. Let's move to, unfortunately, the video demo, if I can skip now. There we are. Sorry for this. There we are. Okay, so in here now, we will see that we will receive the message based on the key. What we'll see on top of this is that once, yeah, unfortunately, is not shown correctly, the complete video. There we are. Okay, now I have the two consumers. I will start creating other food orders here. And depending on the color, yes, I will receive either at the top or at the bottom. So Fox goes at the top, unicorn at the top, and giraffe at the bottom. And this will be consistent. So the next time that I will generate another order for the giraffe, I will receive always at the bottom. This is because I'm keying my messages based on the caller ID. Now, I can click on Pizza Done in my pizza makers. This will create a new event into a new topic called Pizza Delivery that I will be able to check with a new page. This is where you can create other pages, like in this case, every time I click on the button, I end up in this endpoint passing the ID of the order, and this will produce a new message into a new topic called Pizza Delivery. This will be the topic that my delivery drivers will listen to in order to understand when they will go and pick up a new delivery. Okay, we'll see now the delivery part. And now we will see that all the items that I push, all the buttons that I push on the pizza makers will appear on the delivery. Now, I want to cut short a little bit because the demo failed. But the next interesting part is that as of now, I've been showing you just one way to use Kafka, which is using Flask, using Python to produce or to consume code. This is interesting, but usually Kafka is what I would say a middle player, because it's a streaming platform. So usually it's only taking data from point A to point B. And in companies, we know that point A and point B can be other technologies, such as a database, such as an Amazon S3 bucket. So we need to also understand how we can integrate Apache Kafka with the existing tech ecosystem. In our case, what we will see is that we will take the data from a Kafka topic to OpenSearch, which is an open source data platform that allows you to do fast search. And what we will use is Kafka Connect, which is a component of Kafka that allows you to say, I want to take the data from a topic to another technologies, and Kafka Connect does the magic. So here we have our complete demo that failed a little bit. Now we are going to my code sample, and what we will do is we will create a connector. And with the beauty of Kafka Connect is that you can just define a JSON payload, which is the topic that you want to take the data from, and which is the endpoint that you want to push the data, and Kafka Connect will do the magic for you. You don't have to care about moving the data yourself. So now we see that I have an OpenSearch instance, and with OpenSearch, there is also an option called OpenSearch Dashboard, which is a dashboard tool that allows you to play with the data. I'm now connecting to OpenSearch Dashboard, and after doing a little bit of maintenance, I need to create an index on top of the data that I'm receiving from Kafka. I will be able to query the data. So I'm creating an index pattern here. Check here, this is the pizza order. Is the topic name that I had in Kafka that was moved automatically to OpenSearch. Now that I create an index pattern, I can start querying the data in the OpenSearch index. And look, this is exactly the set of orders that I had in my Kafka topic displayed in another tool. And I didn't have to code anything, apart from writing a JSON document saying which was the topic and where I want to push the data. Now, if I create a new order for a unicorn doing a pizza with sushi and writing an address which is via Giacomo Bonaventura, which I believe it's a known player here in Firenze, this is arriving in all the chains of my Flask application. And now, if I refresh my page in OpenSearch, it will also end up, I don't think you can read, but this is exactly via Giacomo Bonaventura, is the record that I just a few seconds ago pushed with Flask. Now I have that in OpenSearch. This is streaming, this is event-driven. As soon as an event is generated, I create a pipeline of changes, of readers, of consumers of the application that can be the same technology or can be really different technologies. I want to say a disclaimer here. I said I wasn't suggesting anything to you. I won't say I didn't force any giraffe, unicorn, or fox to eat any of the pizza, specifically the ones with sushi. I want to leave you with some references. The first one being the slides of this talk that you can find at the top URL or scanning the QR code. Second is the GitHub repository. Third one, it's Ivan.io, the company that I work for. We offer database in the cloud that, unlikely my demo, they work all the time. I'm here for all the questions that you might have. Thank you very much.
Thank you very much, Francesco. So we have a bunch of questions here. I'll take the first one. You've used a remote Kafka cluster for testing. Is there a local standalone alternative, such as a bundled over Docker?
So the beauty of working for a company like Ivan as a developer advocate is that all the tools that we show here are open source tools that we manage as a service in the cloud, but you can find the software, you can download Apache Kafka and use it on Docker and use it in your local computer. You don't have to come with us. It's your choice if you want to manage service with us. But all the source code for Apache Kafka, it's there for you to use it.
Okay, so the second question, where is the Kafka topic allocated? On the client side, on the server side, or is it shared between the two?
The Kafka topic is on the server side. One thing that I didn't say, Kafka is not just one server, it's a distributed system. So it has all the beautiful things about being resilient to failures and having the data scattered across nodes. So it's really a system designed for huge use cases, but you don't have to have a huge use case to start using Kafka. You can start small and then evolve, and the same infrastructure will work for you at any scale.
Serialization is not always straightforward. Is it handled directly by Kafka, or some external library is needed? Is it also possible to exchange complex objects instead of simple values?
Yes, okay, serialization is not an easy topic, I agree. With Kafka, you have several things to do. First of all, Kafka can be the, how can I call it, the dumb player in the room. Kafka doesn't care about what you push into a topic. You can push anything. You can push a number, and then a string, and then a JSON payload. Complex, doesn't care. But you can use Kafka in a smarter way, where you basically use a tool called Schema Registry, where you define for a certain topic what is the schema that can be simple or complex. And then the beauty of using a tool like Schema Registry is that, let's say that you have a JSON payload that you want to send. JSON is beautiful because you can read through every field, but JSON has the problem that is heavy, because for each field, it has the field name and the field value. With Schema Registry, you can take out all the field names, send them to the Schema Registry, crunch all the remaining stuff, and send only the remaining stuff over the wire. So having a much better throughput, because you are sending for the same amount of information, much shorter payload.
Okay. How should we handle updates to the schema of the events? I think
it's a complex topic. With Schema Registry, you can define if a topic needs to be backward compatible or only forward compatible. You have several options to say refuse a message if the schema of the message doesn't comply with what I wrote in Schema Registry. By the way, Schema Registry, the one that we use in our tools, is called Carapace, is again another open source tool. So you can take that and use it as well.
How does the endpoint that receives the orders updates? Is it done by Kafka or is it Flask? Thanks for the talk.
So how is the consumer receiving the updates?
Yes, the endpoint that receives the order updates, how does it update?
So the consumer that we had here was a never-ending loop. This is probably the very basic way of handling a consumer. You can have a polling mechanism if you want. The reality is that the consumer will poll Kafka in order to receive the events. It's not Kafka that is sending to the consumer.
Okay. The last question, what does Avon offer over managed Kafka in the typical cloud providers like Azure or AWS?
It's a very good question. Basically, this is the true open source Kafka. With Amazon, you have Amazon MSK, which is a cut-down version of Kafka. With other providers, I can name Confluent, you have Kafka on steroids. What we offer is Kafka. The beauty of it is that it's your choice to work with us. It's reliable, 99.99% SLA. If you want to use Kafka without having any headaches, and also if you want to be free to switch to something else, to some other providers, we are your choice. We offer our work, it works on all the major clouds. And we have ways of moving, for example, from Amazon to Google Cloud, or from two different regions of Google Cloud. So it's about having a choice. We are dedicated to open source. We are dedicated also to contributing back to open source. So we have maintainers of Apache Kafka working with Ivan. It's a choice.
That's all. Thank you very much, Francesco.
Thank you very much.